Good morning, everyone. Thank you for joining us for this early session. Depending on where you are, it could be very early for some folks. And I'll just start sharing my presentation. Yeah. So as John said, this our presentation is remote bathymetry processing solutions for onshore and offshore operations. It's a joint presentation between Teledyne, CARIS, and Ocean Floor Geophysics. So, sorry, just getting my notes. In recent years, it's becoming more and more common for hydrographic offices, academic institutions, and private industry companies have been demanding solutions for remote production and training. Migration to a remote work scenario is challenging because there's new security concerns, evolving technology needs, and changing workflows. So through a project funded by Canada's Ocean Supercluster, sorry, just lost, there we are. Teledyne CARIS, along with its project partners, Ocean Floor Geophysics, the Marine Institute of Memorial University of Newfoundland, the University of New Brunswick's Ocean Mapping Group, CIDCO, and H2I have formed a partnership to advance and support cloud-based software for remote work, remote operations, and remote training, right? So that this is going to apply to a wide, our goal is to make this apply to a wide group of people. So what's the state of things today? Well, traditionally, on your survey platform, you'll acquire your data, and maybe you'll do some initial processing offshore, right? Then you bring it back to the office, and once you're in the office, from there you do your post-processing and post-processing chart production, and whatever other products you need to make. There are some current cloud services out there. One of them that I can mention right offhand is our F100 service that we launched recently with Primar, as an example of a cloud processing service. But for the most part, it's a very isolated process, right? Data from the ship to the office, and then finally you can push it to the cloud. This can introduce a lot of delays. Right, the time to get the data from the survey platform into the office, for example, is a significant source of processing delay. So how do we see this changing? Well, I have this broken up into two parts. We have the near future and then further into the future. So in the near future, what we see is an increasing reliance of web-based services and virtually hosted desktops. So our vision for the future of processing in the near future is you still have to do your survey offshore. Obviously, that part's not going anywhere. And maybe you'll do some of your initial processing. But then we'll push data via a data transfer portal to cloud-based storage. And then from there, using virtualized desktops, people can use their post-processing programs to work directly in that manner. Also, an increasing reliance on services. There's a few more web-based services we see coming. And so how does this benefit people? I won't get too deep into it because Allison is going to come in a few minutes with some use case examples. But basically what this allows people to do is to no longer need to be physically located where the processing software is. Right, that's the big advantage. It also allows for easier scaling. Right, for instance, you don't need to go buy another computer if you need another processor. You just request another desktop and it gets spun up. And again, this increasing connectivity will also allow for increased use of web services and thereby allowing different delivery methods than maybe we've used in the past. What do we see as the future of hosted apps? The future of hosted apps is more of an evolution of what we see as our short-term goals, which is an ever-increasing reliance on services. And so as you can see from the diagram that I have up, what we envision is having direct connection from the services. So you won't need to manually push data up to shared storage and then use it. You'll be able to directly have that direct connection between the two of them. And by increasing and building up the amount of services that we have, this also allows for the creation of native web apps. There will still be virtualized desktops and our desktop software for a while to come because many people we recognize, are going to have security restrictions that are not going to allow them to fully go into using web services. But we think that this is really going to make processing more efficient, easier to pick. It's going to be more efficient. It's going to be less travel for people, which reduces many types of risks and security issues. And so, let me go to the next slide. I'm now going to hand this over to Allison and let her, So I'm going to hand this over to Allison. Allison is our partner, as John said in the intro. She works for ocean floor geophysics. And so, yeah.
Morning, everyone. So Ocean Floor Geophysics has been conducting offshore field trials with our Hugin AUV to support this initiative. And so I'm going to discuss a few of the use cases that we're investigating, and then I'll discuss some of the technologies that we're using and where we're at right now. So the first use case, Mark, yeah, thanks, is remote offshore processing. So this is where we move the processing team from the vessel to shore. Now, there are some significant benefits to this architecture, but we collect with our Hugin AUV more than 1 terabyte of data a day. So it's really not reasonable to send all of the data, raw data, across satellite-based vessel internet up to the cloud for processing onshore. So we need to come up with a different way of managing the data processing workflow. So given that the data has to stay on the vessel, and we have our team onshore trying to process it, how do we make that so that it's a good working environment? So vessel-based internet has limited bandwidth and always has a fairly significant amount of latency compared to what you would have at your office or home. So in order to be successful, we needed to make sure that the process we're using is robust to dropouts of vessel internet, because that also happens all the time, and also doesn't use so many mouse clicks, because clicking the mouse on many times is very slow and frustrating. So our approach has been to automate the data processing workflow on the vessel, so that we can, so that the data processor can more easily manage the workflows from a remote location, and also so that it can run without intervention in case the vessel internet actually goes down. So in this case, the data processor, instead of manually processing the data, is actually managing automated workflows and performing quality control at various stages in the process to make sure that everything is going well. And to do this, we've used CARIS on board along with Process Designer, and eventually we'll also be introducing Mira AI cleaning, the automated cleaning system that is produced by CARIS. So once this is fully up and running, then in theory, what we need is a data manager on board who can investigate things using the traditional tools when if things aren't quite right, and an IT person to support the significantly different IT infrastructure that's required. But the rest of the data processors, in theory, should be able to work from a remote location anywhere in the world and just log into the vessel. Now, this has some, the benefits of this, we have a lot less people offshore, so that lowers your HSE risk for the project. In the current climate, it mitigates the need for international travel, or reduces the need for international travel, which mitigates quarantine, trouble, and all of the other risks that are currently associated with trying to get a team, an internationally based team to a vessel. And it allows us to scale up and scale down as required, because the processing team is not constrained by crew changes. So I can bring in specialists for different events in the processing or in the survey. And I can, if we are getting more data than we can manage, we can just add more people. But the disadvantages, this does require significantly more intense IT infrastructure, right? It's not just a bunch of people and computers on board. Now we have to have high bandwidth satellite communications. We have to have security to make sure that there's no one can gain access to our data that shouldn't have access, or to the vessel that shouldn't have access. And our team starts to need to have new skills to be able to manage these things. And in order to be fully autonomous, we have to develop that autonomy. So there is a significantly there's a significant effort in developing the autonomous workflows to enable this to go on. Mark, can you put us in the next slide? So the second use case is the globally located onshore processing team. And this is where we decentralize our onshore processing with people that can work from home anywhere in the world. This is using the tomorrow software, the software that's available tomorrow in Mark's discussion, where we have our centrally located servers, or we're using a cloud system like AWS, and we have our virtual workspaces, and then our processing team is located wherever. They just log into our system, and then they're able to work from home. So the big benefits of this is it allows our onshore team to be chosen from the global talent pool. So we're not constrained with people who are within commuting distance from our office. And this is a huge benefit. And again, it allows us to easily scale up and scale down depending on how much work we have and what our deadline is. So we can just add more people to the problem if we find ourselves lagging behind in the processing. And then also, it actually pushes all of the specialized hardware that we need for doing our work to somebody else's responsibility. So all of the GPUs and big big processing computers, those are actually resident in the cloud now. And our processing team can work on just normal desktops. So that reduces the amount of infrastructure that we need to support as a company. Of course, the disadvantages, again, this requires bandwidth. And there are some increased logistics getting the basic things to people to be working from home. So we may need to be sending monitors around the globe to make sure that that our data processors have proper workstation that they can work from. It also means that we need to have a much better structure for team management and communication. We don't all just show up at 9 o'clock in the morning to the office and have our coffee and water cooler anymore. We have to schedule meetings and make sure that everyone is tracking on the same page and doesn't, so that we keep that team environment even though we're separated by space. And then, of course, again, we need to consider data security, and we also need to consider data sovereignty. So some of the time when you're working on international projects, the country where you're working doesn't actually want the data to be leaving the country. And so you need to look at creating these instances of your virtual workspace in the country or region that is approved for your data. Can I go to the next slide, Mark? So some of the enabling technologies that are making this possible right now, for vessel-based work, we now have access to high bandwidth satellite communications. So good network connectivity, this is an essential part of making sure that this can occur, and we're starting to be there. There's been a lot of improvements and innovation in satellite communication lately, and now with you can get a dedicated or shared satellite connection with 20 megabits per second of bandwidth and more than 50 megabits per second of burst capability. So this is enabling us to start thinking about having our data team located remotely and communicating with the vessel. But again, there is that extra vulnerability that comes with having a cloud presence and not just handing data back and forth on hard drives. Next slide, please. So we actually we're in the middle of testing these things in the field, and we've had to develop a number of collaboration tools to facilitate the work. And one of the few of the things that we found that are really, really useful for managing this is to manage the use case of a remote processing team. So we need to manage the communication between the vessel and our onshore team. And so we've developed a few collaboration tools which we can use to kind of facilitate that environment. And what we discovered was that we want to make sure that the onshore team knows what's going on without having to go and ask what the offshore team what's happening. So we created a chat server which allows the teams to communicate between each other, but also then we used bots to make announcements on the chat server, which keep everybody informed of what's happening, like when data has arrived, when a transfer's been finished, when backups have been completed, and those kinds of things. And then we have a dashboard which displays the mission parameters and other information so that the onshore team knows when the AUV is going to be getting up to the surface and that sort of thing. And then we've also got synchronized storage, and then using like TeamViewer for remote access in case we have to do extra things, like, for example, using Graph Tool or other Kongsberg software to analyze AUV navigation, or just delving deeper into the data beyond what we can do over the network communication. So next slide. So offshore trials, we've actually started this. So ocean floor geophysics have been putting the all of these theories to the test, and we started an offshore project in September 2020, and we had fully automated offshore workflow process and workflows implemented, and we were able to successfully demonstrate that we could use the CARIS tools to process data on the boat using a person who is located in Canada. This person was located in Canada, and it was really cool. We put together a lot of automated processes in order to be able to successfully go from the AUV coming on board, delivering data, and then after that, everything just ran on its own all the way through to the data products being produced. So the development and testing will continue throughout this year, and culminating in some large demonstrations of the existing CARIS tools and the ones that are going to be developed. And last slide. So that's the end of my presentation, and we'd just like to acknowledge all of our partners and Canada's Ocean Supercluster for helping to support this work.